Okay, this video accompanies the 3.1 definitions page, which is our part of our Chapter 2 review pages. And this first section deals with definitions. There are a couple of definitions that we need to be sure we go over. And let me make sure this is plugged in. And one of those definitions is the idea of skewed lines. We didn't really talk much about that, if we did any at all. So let me just kind of go over the skewed line definition right here. In three-dimensional space, we could have a line, say this oriented that way, and let's say this is like the screen. This is like the screen right here. Well, now back in the back, we could have another line, say at an angle, that basically goes back this way. So it doesn't cross this line. This line's in the front, and this other line passes behind it. So now we're talking more about three-dimensional space. So we've got this one line here that comes out and goes back in this way. And then we've got this other one, say, that is on like the front face of this rectangular prism here. And so these two lines aren't parallel to each other. They're not parallel. They don't intersect. And they are not coplanar. So this is the one case where you can have two lines. Like normally the normal case is in a plane, two lines are going to be parallel, which means they don't cross, no intersection. They could coincide, which means basically they are two different equations, say, of the same exact line, so they kind of graph on top of each other. So that's like an infinite points of intersection because they overlap every place. Or we'd have the case where they cross each other and they intersect at a point where we can find the x and the y using like systems in algebra, or by reading on the coordinate system, the intersection, or the x and the y that go with where they cross. That gives like one point of intersection. So these are kind of like the normal cases that we deal with in plane geometry. But if you open it up to 3 dimensions, then we have this other situation where you can have two lines that basically are oriented in different directions, and they don't cross each other, yet they're not parallel to each other. They don't intersect each other, and they're not in the same plane with each other. The other thing we should mention is that anytime you have two lines that intersect each other, there's a plane that we can imagine that goes through those. So those are coplanar. Anytime you have two lines that coincide, there's an infinite number of planes that could slice through those two lines, even though they graph on top of each other. They're also coplanar. And two parallel lines are going to be coplanar. We can always think of a plane that goes between those two parallel lines. So the skew case is the one time when you have two lines that don't intersect, yet are not in the same plane with each other. So that's a good one to know. So let's move on and see what we have coming up with the rest of these then. So let's go on. So parallel lines, coplanar, don't intersect. Picture. Skewed lines, they're not coplanar. They're neither parallel nor intersecting. And parallel planes. Now parallel planes, here's an example of parallel planes. They don't intersect each other. And all planes either are parallel to each other, which means they don't intersect, or if there's a little bit of a tilt between them, they're going to basically intersect each other at some place in a line. See if I can draw that situation. So we'd have one plane, say, that's coming out this way. We'd have another plane that's going back down this way, like this, sort of an angle with each other. And the place where those two planes intersect each other is going to give us a line. So here's a picture of intersecting planes. Here we have a set of parallel planes. So we need to complete these statements with always, sometimes, nevers. So two lines in the same plane can sometimes be parallel. Not always, but they can sometimes be parallel. If two lines are in the same plane, they are never skew, because skew lines require that they be in like a three-dimensional type case, so they're not going to be coplanar with each other. So two lines in the same plane are never going to be skew. And two non-coplanar lines, now two non-coplanar lines are also never going to intersect. If we have a non-coplanar line with another line that's not in the same plane, then those lines could be skew, which means they're not going to intersect. But if they did intersect, like in an X-type situation, we could think of a plane that would actually make those coplanar. So this is also a never. Two planes sometimes intersect. They're either going to intersect or they're going to be parallel. A line and a plane have exactly one point of intersection. Now, if we think of a line as being contained in a plane, the points on this line are always going to be part of the plane. That's lots of points of intersection. But if you have a line, say, that is tilted and comes down and passes through the plane and out the other side, that would be a case where there's only one point of intersection. So this would have to be a sometimes. So the two sometimeses are number 1 and number 5. And if two planes do not intersect, then they have to be parallel. So that's going to be an always. Okay, let's move on. Name two lines in a transversal that form each pair of angles. Okay, let's look at this example. In this example, we want to name the two lines in the transversal that form each pair of angles. So they're talking about angle 1 and angle 4. So if we look at angle 1 and angle 4, one thing we can notice is these are alternate interior angles. And with alternate interior angles, you can always kind of visualize a Z, either a regular facing Z or a backwards facing Z. So if we look at the two horizontal pieces of the Z as being the BC and the AD segment, the crossbar then represents the transversal, and we can see that angle 2 and angle 3 are alternate interior angles. Doing the Z the other way, if AB now becomes the horizontal part of the Z and CD is the other horizontal part, we have BD here as a transversal, and that shows us that angle 4 and angle 1 are alternate interior angles. So if BA is parallel to CD, we can say that angle 1 has to be congruent to angle 4 because those are alternate interior angles. If BC is parallel to AD, we can say that angle 2 and angle 3 are congruent because those are alternate interior angles. Okay, let's look at the exercises now on the next page. So for number 7, we want to name two lines that and the transversal that forms each pair of angles. Now these lines, they're not telling us that they're parallel to each other, so we can't say that the angles are congruent, but we can identify them in terms of their position in the system of two lines cut by a transversal. So if we look at angle 1 and angle 2, we can see that they're in corresponding positions. They're both above the transversal line, and they're both to the left of the two lines that are crossed. So these are corresponding angles. If we look at 2 and 3, 2 and 3 are alternate interior angles. They're on alternate sides of the transversal line, and they're both inside the two lines that are crossed. That makes them alternate interior, and we can abbreviate that with AI. So now, if these lines were parallel, we could say that the corresponding angles would have to be congruent, and we'd have to say that angle 2 and angle 3 would have to be congruent, because those would be alternate interior angles with parallel lines. In this situation, all we can do is just identify them in terms of like how they sit in the diagram. Let's look at number 8. Angle 4 and angle 5 are a pair of alternate interior angles. Angle 4 and angle 6 are corresponding angles between line B and line D. So 4 and 6 go with line B and line D, and those are corresponding angles rather. They're both on the same side of the transversal. They're both below the two lines that are crossed. So those are corresponding. And 4 and 5 then depend on B and C for the lines, and then line A is the transversal line. Let's look at number 9. Okay, angle 1 and angle 2. If we look at BA and CE as being the parallel lines, with AC as being the transversal, then we have angle 1 and angle 2 as alternate interior angles. And that's using BA and CE as the lines. If we look at angle 2 and angle 3, angle 2 and angle 3 are alternate interior angles if we use CA and DE. So using CA and DE, we have angle 2 and angle 3 are alternate interior angles also using those lines. Let's look at number 10. Angle 5 and angle 6. Here's angle 5, here's angle 6. If we look at GH as one of our lines, and HK as our other line, then angle 5 and angle 6 are corresponding angles. And angle 7 and angle 8, if we look at HG and HK, angle 7 and angle 8 then would be alternate interior. And here we can kind of see how this Z helps us pick out the alternate interior angles. So these are AI, alternate interior. Let's move on. When two coplanar lines are cut by a transversal, some of the angles formed have special names. Now, exterior angles, 1 and 5 would be alternate exterior angles. 8 and 4 would be alternate exterior angles. If the lines were congruent or were parallel, then these alternate exterior angles would have to be congruent. Interior angles, 2 and 6 would be alternate interior angles, and 7 and 3 would be alternate interior angles. And then 4 and 2, 3 and 1, 5 and 7, and 6 and 5 would be the corresponding angles. So I'll asterisk the alternate interior angles are special if the lines are parallel. Same side interior angles are supplementary if the lines are parallel, and corresponding angles are congruent if the lines are parallel. In terms of just exterior angles, the outside angles 1 and 8, 4 and 5, interior angles 2 and 7, and 3 and 6. But the ones with the stars are the ones that we can actually do something with. Alternate interior angles are going to be congruent if lines are parallel. Same side interior angles are supplementary, which means they add to 180. And corresponding angles are going to be congruent. Okay, let's move on. Classify each pair of angles as alternate interior, same side interior, or corresponding angles. So let's look. Angle 2 and angle 4, we can see that they're corresponding. They're both above C and both to the right of A and B. So those are corresponding, CORR. 10 and 11 are same side interior using A and B with D as a transversal. Those are same side interior, SSI. 14 and 15 are also same side interior angles. They're both below D. They're in between A and B. And so they're interior, and they're both the same side of the transversal, same side interior. Now there's nothing about these being congruent because these lines aren't parallel. 7 and 12, here's 7, here's 12, alternate interior. 5 and 10, alternate interior. And 3 and 11, 3 and 11 corresponding. They're both to the left of B, and one is above C, the other is above D. That makes them corresponding. So corresponding is like same side, same side. Let's look at 17 with this different diagram. Okay, now they're giving this in terms of the three-letter way to name them. So we've got angle STU and SZX. So STU and SZX are corresponding. Look at 18, WXZ, WXZ, and YZX. So we've got WXZ and YZX. These are same side interior. So sometimes it helps to kind of, especially if you have pencil, to kind of mark up the diagram to identify the angles if they're in a complicated pattern. UTZ is this angle here with VZY. VZY, UTZ, we can see those are corresponding. Number 20, VXT. VXT goes back this way. And we have UTX, VXT and UTX. Where's UTX? So VXT, UTX, these are same side interior. QTZ, Q to T to Z is this angle here, along with VZT. VZT is this angle here. These are, if you see the Z there, these are going to be alternate interior. VXT, V to XT is this angle here with XTQ. VXT, XTQ, here's the Z. These are also alternate interior. WZX, WZX, wait. WXZ, WXZ is this angle, and YZP, YZP, these are corresponding. They're both on the right side of line VP, and they're both below. One's below line RW, and the other's below line SY, so that makes those corresponding. And then QTZ, Q to T to Z is this angle here. And we have PZT. P to Z to T is this angle here. These are same side interior angles.